Hello, boys and girls. Welcome back to another edition of Crush Lusher Television. All right, today we're going to work on the scrimmage. So this scrimmage problem number 14. Do you know your asymptote from a hole in the graph? I don't know. You are not allowed to use a calculator, and here is the function. So I'm going to do part A, B, C. Part D you don't know how to do yet, okay? So A, B, C, copy it down right now, and try and do the whole thing without my help. So pause the video right now, try and go through A, B, and C, and see how far you can get. And then you can compare your answers with mine. Don't just watch it and write it down. You're not really learning that way, okay? So always try the problems first yourself, and then you learn from what I do, whether you get it right or wrong, okay? Then just fix it. Not a big deal. All right, so here we go. So what do I have to do? So I got this piecewise function. When x is less than 0, you got this funky thing. When x is 0, you got 2/5. And when x is greater than 0, you got this. So I want to find the limit as x approaches -3 of f of x. Okay, so there we go. So here we go, I copied it down. And so the limit as x approaches -3 of f of x. So -3 is less than 0. So this is the part we're going to plug in, okay? So that's going to be -3 to the third minus 5 times -3 squared plus 6 times -3 divided by -3 to the third minus 2 times -3 squared minus 15 times -2. Sorry, -3, my bad. So we got all this. So I'm just going to simplify this. We can use a calculator. So -3 to the third is -27. This is -3 squared, which is 9. 9 times -5 is -45. And then this is 18, like that. Sorry, -18, my bad. Okay, let's see what we got on the denominator. -3 to the third is -27. This is 9 times -2, which is -18. And this is negative times negative, which is positive 45. So the numerator, you're going to get -27 and 45 and 18, so you got to add those together. 27, 45, 18. Add those together. No calculator, you just got to do it by hand. So that's 12 plus 8 is 20. Bump to 2, 4, 8, 9, 90. So it's -90. And this is -45 plus 45 is 0. Cool. So we have an undefined limit. So this means we have a vertical asymptote or an infinite discontinuity at x equals -3, because it tells you to name what the discontinuity is right here. So identify the type of discontinuity. Bam. So we got that. Part A done. Good. We good. All right. Part B. Find the limit as x approaches 2 of f of x, and then describe any discontinuity we might find. All right. Cool. All right. Here you go. So limit as x approaches 2 of f of x. All right. So that's going to be here. I'm focused on this part because 2 is greater than 0. So this is the part of the graph you're looking at. So limit as x approaches 2 is going to be 2 to the third minus 4 times 2 over 2 to the third plus 3 times 2 minus 10 times 2. All I'm doing is I'm plugging in this part right here. Plugging in 2 right there because 2 is greater than 0. All right, let's see what we got. 2 to the third is 8 minus 8, which is 0. This is 8 plus 3 times 2 is 6 minus 2 to the 3 times 2 minus 10 times 2. So this is going to be 2 to the third is 8 plus 6 minus 20. So 8 plus 6 minus 20. Did I write that down? Let's double check to make sure I wrote it down correctly. Plus 3x squared. Oh, it's x squared, right? My bad. X squared. I copied it down wrong. 3x squared. Here you go. 3x squared. So that's going to be 4 times 3, which is 12 minus 20. My bad. So 8 plus 12 is 20 minus 20 is 0. 0 over 0, we have indeterminate. So therefore we have a hole in the graph at x equals 2. That's a discontinuity, but I still have to find this limit. So what do I gotta do? Oh yeah, I gotta factor. All right, so how do I factor this thing? So I'm looking here, I can take out an x, can I? So I'm gonna take out an x. And here I'm also gonna take out an x. Bam. So x divided by x is 1. And so now I can plug in 2 again and see what I get. Let's plug in 2 again. So that's going to be 2 squared minus 4 over 2 squared plus 3 times 2 minus 10. 2 squared minus 4 is 0. 2 squared is 4 plus 6 is 10 minus 10. Ooh, I got indeterminate again. Oh my goodness. So what do I have to do? Oh yeah, I got to factor this again. So I plugged in 2 the first time, got 0 to 0, factor out an x, got 0 to 0. And so now I need to factor this again. So this is going to be 0 on the top, negative 4 on the bottom, which is 2 and negative 2. 3 on the top and negative 10 on the bottom, which is 5 and negative 2. Cool. So you factor the numerator, factor the denominator. Cool. We still there. So it's x plus 2, x minus 2 divided by x plus 5, x minus 2. So we're finding the limit as x approaches 2. Make sure you write the notation next to it. So when people read your work, they understand what's going on. So then I plug 2 in here. So it's 2 plus 2 over 2 plus 5, which is 4 sevenths. So we got a hole at x equals 2, and 4 sevenths is the limit. That's what you're going, the y value you're approaching as you go from left and right. All right, next. Is f of x continuous at x equals 0? Almost done. All right, so that would mean the limit as x approaches 0 from the left of f of x equals the limit as x approaches 0 from the right of f of x. That's the first thing you have to prove, so that there's no jump in the graph if you're going towards a different y value. And we got to make sure you're going towards the same y value. So 0 from the left is this, so I plug in 0 here. So when I look at this, when I plug in 0, 0, it's all going to equal 0. So I know it's going to be 0 to 0, so I need to factor out an x to start. So this is going to be x times x squared minus 5x plus 6. And then x, you factor an x from the denominator, you get x squared minus 2x minus 15. Bam. So when you factor out an x there, and x divided by x is 1. So this is what's left. And so I'm going to plug in 0 here, actually. That's going to help me. So that's going to be 0 squared minus 5 times 0 plus 6 over 0 squared minus 2 times 0 minus 15. So this is 0, sorry, my bad. You can't see. 0, 0, 0, 0. So you have 6. And this is negative 15. So 6 divided by negative 15, you need to divide that by 3, which is 2, negative 5, so negative 2/5. So that's the limit as x approaches 0 from the left. The limit as x approaches 0 from the right is going to be this right here. And I know when I plug in 0, everything is going to be 0, 0. So I need to factor out an x, which I already did right here, which is totally cool. All right, nice. We're doing good. Okay, so here we have the limit as x approaches 0 of f of x. So I'm going to plug in 0 here. So it's going to be 0 squared minus 4 over 0 squared plus 3 times 0 minus 10. So I have negative 4 over negative 10. And so I divide that by negative 2, and you have 2/5. So when you're approaching from the left, you're approaching negative 2/5 on the y. When you're approaching from the right, you're approaching positive 2/5. So there's a jump in the graph. It is not continuous. No. So no, f of x is not continuous. You always have to write this concluding statement at x equals 0 because oh, sorry. The limit as x approaches 0 from the left of f of x does not equal the limit as x approaches 0 from the right of f of x. Cool. There we go. A, B, and C. Hopefully you did well. If not, do it again. Good work, everybody. Take care.